Last unit, or actually way before that, we learned about conjugates. Now, conjugates were things that combos where they were the same exact thing, but one's being added, one's being subtracted. What's neat about conjugates is the middle term always disappears, which is beautiful. But I want you to notice there's something extra special that happens when radicals get involved. So let's watch what happens. 2 times 2, of course that gives me a 4. 2 times negative square root of 3, it's going to be negative 2 square roots of 3. Square root of 3 times 2, it's 2 square roots of 3. Square root of 3 times negative square root of 3 is going to be negative square root of 9. Look at those middle terms every single time. They are going to just go away. Now I've got 4 minus the square root of 9, which is 3. I just got 1. No more radicals. See what happens over here. Square root of 3 times the square root of 3 is going to give me 3. Actually, let's back up that square root of 9. I want to make sure I show every step. Square root of 3 times square root of 5 is going to be square root of 15. Negative square root of 5 times square root of 3 is going to be negative square root of 15. Negative square root of 5 times a positive square root of 5 is negative square root of 25. Square root of 9 is 3. Middle terms, how nice. Minus the square root of 25, which is 5. And I get negative 2. Now, why is this a useful thing? Well, let's just say I had 2 over 3 minus the square root of 2. Now, you might want to try rationalizing the denominator, because we have a radical down there, which is bad, 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 bad. Now, let me show you what the common mistake people will try to make. When we just had a radical all by itself, we would multiply the numerator and the denominator by square root of 2, right? Well, watch what happens here when we do that. 2 times the square root of 2 is 2 square roots of 2. 3 times the square root of 2 is 3 square roots of 2. Minus the square root of 2 times the square root of 2, which is 2. The radical's still there. That didn't work. So let's try another approach. I still had a radical left when I tried that way. There is a technique called multiplying by the conjugate. Well, let's think about what conjugates are. Conjugates are binomial, where both terms are exactly the same, but on one we add, on the other we subtract. So, if this one is subtraction, let's try multiplying by the conjugate, which would be to add them. So let's see what happens when we do that. I'm going to multiply. So that means I'm going to distribute the top. 2 times 3 is going to be 6, plus 2 times the square root of 2 in the denominator. 3 times 3 is going to be 9. 3 times the square root of 2 is going to be 3 square roots of 2. Negative square root of 2 times 3 is going to be negative 3 root 2. Oh my gosh, those middle terms. And then minus square root of 2 times square root of 2, which is just going to be 2. Amazingly enough, I know it's shocking, every time you multiply conjugates together, the middle terms add away. They go away. So 9 minus 2 is just going to be 7. You have rationalized the denominator. I mean, and it doesn't matter if it gets even more complicated. So I'm going to do a really ugly one. It does not matter how ugly it is. All we're caring about is getting those radicals out of the denominator. So we need to multiply the numerator and the denominator by the same thing. Well, since we looked at this example, let's go with multiplying by the conjugate. Now we're multiplying by the conjugate of the denominator. So if this is square root of 2 plus square root of 5, the conjugate would be square root of 2 minus square root of 5. Now, I did do a more complicated one because I wanted to show you that you're going to have to distribute numerator and the denominator. So that means FOIL, if you want to use the simpler term. Square root of 3 times the square root of 2 is going to give me the square root of 6. Then I'll have the square root of 3 times the negative square root of 5, which is going to be square root of 15. Square root of 2 times the square root of 2. Oh, that's nice. Square root of 2 times square root of 2, that's just 2. And then square root of 2 times negative square root of 5 is negative square root of 10. Ooh, that didn't turn out very nice, did it? But doesn't matter. All we're trying to do is get rid of the radicals in the denominator. Numerator's fine. Square root of 2 times square root of 2 is just going to be 2. What's going to happen to the middle terms? Are they going to just go away? Yeah. But we'll go ahead and write them. Square root of 2 times square root of 5, negative square root of 5, that's negative square roots of 10. Square root of 5 times square root of 2 is positive square roots of 10. Square root of 5 times negative square root of 5 is going to be a negative square root of 25, which is just 5. So the numerator, we don't have any like radicals. Can't do anything there. Here, those middle terms go away. I have 2 minus 5, which is negative 3. I am done. That is all you have to do to rationalize the denominator with conjugates.